AB is a variable line sliding between the coordinate axes in such a way that A lies on the x-axis and B lies on y-axis. If P is a variable point on AB such that length of PA equals B, length of PB equals B, and the length of AB is A plus B, we need to find out the equation of the locus of the point P. So let's try to set the problem first. So here we have the two coordinate axes, the x-axis and the y-axis meeting at the origin over the coordinate 0, 0. Now we're going to consider a line AB. Now AB is going to be touching the x-axis at point A, and the other end, which is B, is going to be touching the y-axis. So let's join point A and point B. Now since the one end of the line is going to touch the x-axis at point A, we're going to name the coordinate of that point as alpha, 0. There is going to be no y coordinate here. And the other end of the line is touching the y-axis at point B. So let's say its coordinate is 0, beta. Fine. Now let's come to the other part of the problem. It's given here that P is a variable point on AB. So let's say we take a point P on the line AB such that this particular point, such that PA is given here. PA, the length of PA will be equals to B, and the length of PB, that's going to be equals to A. And we also have length of AB, that's going to be A plus B. Okay, so our goal will be to determine the equation of the locus of that particular point P. That means here we have a variable line. So on that variable line, we have a point P, which divides the line into ratio A is to B. So our goal will be to determine the equation of the locus of that particular point. So what we'll do, we'll first consider that the coordinates of that particular point, let it be given by h, k. Fine. So what we'll do, in the first step, we'll try to find out, we're going to find out the coordinates of point P using the section formula, because here clearly P is dividing AB into ratio A is to B. To use the section formula, what we'll do, we'll take A and we'll multiply with the end coordinate of the end point of the line, which is A, and we'll take this particular B and multiply with the coordinate of the other end point B. Okay, so this is going to be the internal section formula that we will be using. So we'll begin with the x-axis. So what we'll do, first we'll consider A and multiply with the x coordinate of the endpoint A. So we have A times alpha, and we are going to add it to B times the x coordinate of B. So that's simply 0. So this will be 0 divided by the sum of the ratios, which is A plus B. So this is going to be divided with A plus B. Okay, next what we do, we go to the y coordinate. All we have to do is take A and multiply with the y coordinate of A. That is simply 0. And we're going to add it to B times the y coordinate of B. So we have B times beta divided by A plus B. Fine. So now we have the coordinates of point B, but it's already, we have considered that the coordinates of point P are h, k. We have already considered, we've assumed this. So we will say that h, k, that's equivalent to A times alpha divided by A plus B, this is B times beta divided by A plus B. Now if we equate it, we're going to get the value of h as equivalent to A times alpha over A plus B, and we're going to get k. So k will be equals to B times beta over A plus B. Now let's do one thing. Let's write the equation in terms of alpha. So alpha will then become A plus B divided by A multiplied to h, and then k will then we have beta. So beta will be A plus B over B multiplied to k. Fine. Now what we'll do, we'll consider the triangle AOB. So and it's a right angle triangle, it's right angled at O. So in the right angle triangle AOB, we can use the Pythagoras theorem. The Pythagoras theorem states that the square of the hypotenuse AB, that will be equals to the square of the sum of the square of the other two sides. That means we have OA squared plus OB squared. Now what's AB squared? AB squared, that's already provided to us. AB is A plus B. So what we can do, we can replace the value of AB with A plus B. So we're going to get A plus B whole squared. And this will be equals to OA squared. Now what's the length of OA? That's nothing but the x-intercept, which is alpha. So here we can replace with alpha squared. And OB, that's the height of point B from the x-axis. So that's simply beta. So we can replace OB squared with beta squared. Okay, now we have already expressed alpha and beta in terms of h and k. So let's replace that. So we have A plus B whole squared. This will be equals to, in place of alpha squared, we now have A plus B over A whole squared times h squared. And then we have beta squared. Beta squared will become a plus b divided by b whole squared k squared. Fine. Now we have a plus b whole squared as the common factor. We can factor that out. So 1 will be equals to, we have h squared over a squared plus k squared over b squared. Or we can simply say we have h squared over a squared plus k squared over b squared equals to 1. Now what we'll do finally, we're going to replace the value. We're going to replace h with x and the k with y, such that we now get x squared over a squared plus y squared over b squared. This will be equals to 1, and this is the locus of that point, locus of the point P which we are asked to define. Fine. So that's how we can obtain the locus of that particular point P.